looking at function families and identifying functions based on a couple different things. So we know our families, and we know that any of those families need to be functions. They are functions. They behave like functions, or they are the basis functions. So from there, there are going to be a couple times when we'll see things in a table, we'll see things on a graph that don't look like those families, and we need to make sure we have a good indication for them. So determining if something is a function will look like this. If we see it on a graph, we know something like this would be a cubic function. It holds true, it looks cubic, it behaves like it's cubic. We're going to assume that's cubic. We know that's a parent function of that. However, if we look at a graph that looks like this, that's a poorly drawn, but a circle or an ellipse of some type. The issue is we look at it and we see, okay, if I put in, let's say x is 1, I could get out 3, or I could get out -3 or -2, whatever. If I don't know which one I'm going to get, or I could get out 2 possible answers, that's not a function. Okay, so that's a non-function. If we look at something else, maybe like a scatter plot, we have dots a little bit everywhere, and they kind of show up. Ooh, that's close, but not quite. We're looking at maybe one more going right there. Okay, now I immediately see it. I see that there are 2 points given for an input of x. That's also not a function. All right, so if you have 2 points for a given input, 2 possible outputs, then it is not a function. And so we have to classify that as just a relation, and it does not get function status. Also, we can look at a table. So when we look at inputs of x and outputs of y, if I get a repeated input, that's an alarm. It's not necessarily a red flag, but it's an alarm. So I have 2 1s there. If it's, -3 is 7, -2 is 8, 1 is 9, 0 is 10, and 1 is also 3. I see right now that 1 could be 9 and 1 could be 3. This is a non-function. That non-function is here and here. Because I have 2 different outputs for 1, it cannot be a function. This one, x and y, could be -3, -2, -1, 0, 1, 2, and -3, and I get 5, 6, 7, 10, 12, 6, 5. Now, some different things are happening here. Your eye should immediately catch that. Well, now there's 2 inputs that have 6. That's okay. We can repeat an input, repeat an output. It's basically the same name, just for 2 different things. That's okay. Your eye also should catch that there are 2 -3s in this table. If there are 2 -3s, you need to double check and make sure that they have the same output. So I have -3 and 5, and -3 and 5. This is good. This is a function because each input has a unique output. I put in 3, I get 5, or -3, I get 5. Put in -3, I get 5. So let's say we wanted to look at building our own table. We wanted to look at something like a function defined as g of x equals 3x squared plus 2x plus 1. I know right now that's a function because it's quadratic. I see x squared. I know that that's a quadratic function, so I'm good. I know this is a function. I'm just going to build some values out. But we note this as g of -3. So if I'm going to put in x, that means x is equal to -3, and I need to fill that out. So I have 3 times -3 squared plus 2 times -3 plus 1. So when I run this out, I go, okay, -3 squared is 9 times 3 is 27. 2 times -3 is -6, and then plus 1. So I said 27 minus 6, and that's 21, plus 1 is 22. So g of negative 3 is 22. All right, so let's try another one. The coordinate point there, real quick. The coordinate point would be negative 3 and 22. All right, so let's try one defined as h of x is equal to 3x plus 7. All right, so you should already know that that's linear. You see that the exponent is 1, nothing else in there. You see that this is a linear function. You know it's a function. So I want you to define it as h of 4. So go ahead and pause the video, work that out, and then resume it and see if that makes sense, if what we did is right. So looking at h of 4, I have 3 times 4 plus 7. So I get 12 plus 7. So h of 4 is equal to 19. Hopefully you got that right. One more. Let's look at g of, no, let's change it. We've used g a lot. Look at a of x is equal to 2 times the absolute value of x minus 3. And as I look at that, I know that this is an absolute value function. I know that's in that absolute value family. And so I'm going to run through it. I'm going to say a is negative 2. So pause the video again. Try this one with absolute value. Remember what absolute value means. It's the distance from 0, and that can't be negative. Pause it, give it a shot, and come back and see if you got it right. Plugging in a of negative 2, I get 2 times the absolute value of negative 2 minus 3. Negative 2 minus 3 is negative 5, but I'm taking the absolute value of that. So I have 2 times positive 5. So a of negative 2 is 10. Coordinate point be negative 2, 10. So when you give me answers, real quick, but when you give me answers in the form, when you turn your answers in, I just want what it equals. That's all I ever need, okay? So make sure that that's what you put in. There's a couple more that I want. The last ones would be when we define h as h of x equals 2x plus 1, and then I put something else in for x. So let's say I have h of 3a plus 2. This one's a little bit weird. So I'm still going to plug in 3a plus 2 in for x. So let's just do it. So I have 2 times 3a plus 2 plus 1. So notice it's plugged in right where it needs to be. That last one there, so I'm going to run through it. I go, whoop, looks like I'm going to distribute. 2 times 3a is 6a plus 4, then plus 1, so I get 6a plus 5, and that's my final answer right there. All right. Last one I want you to see is if we define g of x as 1/3 of x plus 4, and I want to find g of 3 plus 1. Now notice this pattern's a little bit different. The 1 isn't in the parentheses, it's after. So I need to find g of 3 first, then add 1. So I'm going to take this piece and find it, which is going to be 1/3 of 3 plus 4, and then plus 1. I'm really going to do all of that first. So that 1 just kind of came down here. So 1/3 of 3 is 1. 1 plus 4 is 5, and then that 1 keeps coming. Plus 1, I get 6. So hopefully this makes sense. Always come back to this video if you need more help, and good luck on your work. Just turn your answers to me on the form and let me know if you have any questions.